All right, so today we're diving into something that's, well, it's literally everywhere, but you almost never see it. It's this silent battle that's happening on every single surface around us. It's what determines why that new jacket starts to fade or why the coating on a huge skyscraper suddenly fails. Basically, it's the science of why things last, or, why they don't. Let's get right into it.
Okay, so let's kick things off with a bit of a riddle. What on earth could a super high-tech jacket and, say, an ancient stone statue possibly have in common? I mean, they seem like complete opposites, right? Well, it turns out their greatest strength and also their biggest weakness, it all comes down to one thing: their surface.
And that right there brings us to the big idea for today: surface integrity. Now, this isn't just about how shiny or smooth something looks. We're talking about the deep science of that top layer. Its texture, its roughness, even tiny little defects that are completely invisible to the naked eye. And believe it or not, these microscopic properties, they're what decide if a material is going to do its job or if it's going to fail way, way before it's supposed to.
So, what are the culprits? What actually makes these surfaces give up and fail? Well, it turns out they're under this constant attack, and it's coming from two different directions. You've got the obvious enemies from the outside world, but then there are these other kind of surprising enemies, hidden flaws that were baked in from the very moment they were created.
So on one hand, you have the environment. Think about sunlight. It's constantly bombarding things, causing what's called photodegradation. It literally breaks down the molecular chains and the polymers that make up your jacket. But then, on the other side, the danger comes from the manufacturing process itself. Something like high-speed machining can leave behind these tiny, invisible scars, microcracks that over time can grow and lead to a total catastrophic failure.
And you can really think of this like a chain reaction or a line of dominoes. It all starts with one tiny mistake during manufacturing. Maybe the cutting parameters were just a little bit off. That one mistake creates a rougher surface, full of these micro defects. That roughness then leads to things wearing out way too fast. And boom, eventually you get fatigue failure. A problem that started at a microscopic level just caused a complete breakdown.
But here's the really wild part. This isn't just some niche problem for engineers on a factory floor. The science of surface integrity pops up in some seriously diverse fields. It's the thread that connects our most advanced gear directly to our most priceless cultural artifacts.
Just think about those high-tech protective fabrics we wear. The ones often made with materials like polyurethane. For those, surface integrity is everything. It's the key to resisting aging from sunlight and daily wear and tear. It's what keeps them looking good and staying durable.
Or let's go to the other extreme, something as critical as composite armor. In this case, surface integrity is absolutely vital for its main job: protection. Any little defect, like a broken fiber or just a rough surface, that doesn't just mess up how it looks, it can seriously weaken its mechanical strength and its ability to keep someone safe.
Just look at the buildings all around you. The coatings on the glass and concrete, they are in a 24/7 battle against what's called aesthetic degradation. We're talking about cracking, colors fading, losing that shine, all from just being out in the elements.
And this brings us full circle, right back to that ancient statue. Preserving something like that is this incredible balancing act. The protective coatings they use have to stick to the stone and stick really well, but, and this is the tricky part, they have to do it without causing the slightest visual change that could damage its historical value. So you see, whether we're talking about a high-tech fabric dealing with photodegradation and something called chain scission, which is literally the molecular backbone of the material breaking apart, or we're talking about a priceless historic stone that's at risk of being visually altered forever, the specific challenge might be different, but the core principle? It's exactly the same. The integrity of that surface is absolutely everything, and the consequences when it fails are huge.
Okay, so with all these really complex and varied challenges, how are scientists and engineers actually supposed to solve this? Well, the answer, it turns out, lies in breaking down the walls between all these different fields of study.
The big takeaway here, the key insight from the research, is that getting surface integrity right isn't just some side quest. It's a central pillar for creating better materials, period. It doesn't matter if their job is to look good, to be strong, or both. It is absolutely fundamental to making things that actually last.
At the end of the day, there's no single magic bullet for this. The real solution is an integrative one. It's about combining deep, hardcore material science with the practical skills of surface engineering, and then tailoring all of that to the very specific needs of whatever you're making. It's kind of like a giant puzzle, and you need all the different experts in the room to put the pieces together. So, the next time you see a jacket that's starting to fade or a wall with peeling paint, maybe you'll see it a little differently. Not just as a worn-out surface, but as the aftermath of a constant, invisible battle. It's just a great reminder that true quality, true longevity, it's almost never just skin deep. Which really makes you think, doesn't it? What surface will you look at differently now?